Operations with scientific notation. So now we're going to be working with multiplying and dividing with numbers that are in scientific notation. So we're going to evaluate each product or quotient, and we're going to express the result in scientific notation and in standard form. So our answer should be in both forms when we're done. So we have 6 and 5 tenths times 10 to the 12th power times 8 and 7 tenths times 10 to the negative 15th power. So notice we have two numbers in scientific notation. This is all multiplication here. This is just a stream of multiplication. So I can rewrite things so that we have kind of the numbers that are similar to each other in similar forms together. So I've written my numbers that are in my standard form over here, and my powers of 10 I've grouped together over here. So 6 and 5 tenths times 8 and 7 tenths is 56 and 55 hundredths. And my 10 to the 12th times 10 to the negative 15th, if I go back to my exponents rules, they have the same base. I'm going to keep that base in the numerator. And I'm going to add the exponents. So 10 plus negative 15 gives me negative 3. So now our original direction was to write this in scientific notation in standard form. This is not scientific notation. Notice that my number in my front here is not between 1 and 10. I have something in the tens place here, 56. So this is too large, so I'm going to rewrite this in scientific notation. So pay attention to how we do this, because I think this can be very confusing to take a number that's kind of scientific notation into something that actually is scientific notation. So for right now, I'm only going to pay attention to the problem child here, which is my 56 and 55 hundredths. This is the number that's causing a problem. We're totally fine with this power of 10 at the back here. So I'm only going to pay attention to the 56 and 55 hundredths, and I'm going to rewrite it in scientific notation. So I'm imagining it's just a standard form number, and I'm writing it in scientific notation. So I need to move my decimal one place to the left here, so it's between the 5 and the 6. And since I'm moving one place to the left, I end up with 10 to the first power. So this form here is simply my first term written in scientific notation. That's all I've done. So once I've done that, now I can kind of put this back together. The 10 to the negative third comes back into place. And I can put these powers of 10 together. So I end up with 5.655 times 10 to the negative second. Add those exponents. Our directions said write it in standard form also. So if I write it in standard form also, I come up with this number down here at the bottom. So those are my two numbers, one in scientific, one in standard. Again, we're multiplying those, kind of working with our common forms with each other. And we may end up with a term that looks scientific-like, but it's not actually. So be careful when we're converting that to pure scientific notation. Next one, we're squaring 7 and 8 tenths times 10 to the negative fourth. We're going to square that. Squaring means I'm going to multiply it by itself. So to multiply it by itself, I'm going to do my first term times my first term here, 60 and 8 tenths. And then my powers of 10, I'm going to work with together, 10 to the negative 8th. So I end up with 60 and 8 tenths times 10 to the negative 8th. Kind of scientific notation-y looking, but not exactly, because I have a number that's not between 1 and 10. So if I convert that first number here into scientific notation, it's 6 and 8 hundredths times 10 to the first power. And then I can combine these powers of 10 together and get 6 and 8 hundredths times 10 to the negative 7th power. So there's my scientific version of this number. I'm going to convert that into standard form also, and there it is, looking in our standard form. All right. So that's our multiplication with scientific notation. Let's take a look at some division with scientific notation, and we're going to express each of these in scientific notation when we're done, just scientific. So again, same thing here. I'm dividing, which is really just the reciprocal of multiplication. So I can break this up also. I can break this up into my kind of standard forms here, multiplied by my powers of 10 working together, and just do my division from there. So this is straightforward division. I take out my calculator, I get 1.21, 1 and 21 hundredths, times, and here I end up with 10 to the negative 5th. Now I know we've been working with our exponents, and we've said, you can't leave a binomial with a negative exponent, but we're not working with binomials here, we're working in standard with scientific notation, and scientific notation has to look like this, so you have to leave that with a negative exponent on it. Don't try to rewrite it as 1 and 21 hundredths times 1 over 10 to the 5th power, because then it's not scientific notation anymore. So we're leaving it in this form. There's our final answer for C. And for our last one here, again, we're going to break this up, and we're going to do our division here. So I end up with 9 tenths times 10 to the 7th power. This is not scientific notation again, so I want to rework this 9 tenths. 9 tenths is 9 times 10 to the negative first power. Then I bring that 10 to the 7th power back into play here. So I get 9 times 10 to the 6th power. So multiplying and dividing our numbers with scientific notation. Again, we're working with really long numbers, so we may not be able to fit these on our calculator, but we still can work with them in scientific notation. Again, because that form allows us to work with those really large numbers relatively efficiently.